Welcome back guys to another video on deadlock. So in previous lecture we already started with the deadlock avoidance technique Banker's algorithm and we learned the first three steps of Banker's algorithm. Now today we learn the fourth and the last step which is safety algorithm. So before starting with this safety algorithm, let's revise this concept. So this is the deadlock avoidance technique. So basically we are avoiding our system from the deadlock. Now what we are doing is, suppose there are two processes P1 and P2, both are requesting for resource R2, and suppose the first request arrived for resource R2 is of process P2. So first priority is given to process P2, right? So now we apply Banker's algorithm and we check that whether this request is valid or not. And the validity of the request is checked in first two steps of Banker's algorithm. Now, if we find that this request is valid, then and then we allocate resource R2 to process P2. But remember that this is not the actual allocation. We are only allocate resource R2 to process P2 in background calculation, because right now we doesn't know that whether this request granting this request will leads our system to the deadlock or not. So we are only allocate this resource in background calculation. So in first three steps, we check the validity of the particular request, and if it is valid, then we allocate that resource to the particular process. Now, in fourth steps, we check that after granting this request, our system will lead to the deadlock or not. And for that, we see the safety algorithm. So let's see how this safety algorithm works. Let's take that previous example of providing a loan to our customers, but this time we have available only 30,000 rupees. Now we have three customers, Daniel, John and Smith, and all are requesting for a loan at the same time. So let's check for the request one by one. Now, the first is Daniel, and Daniel needs 32,000 rupees. We have available 30,000 rupees, so we cannot provide a loan, right? Because Daniel's need is greater than the available money. So we tells Daniel that, okay, Daniel, we cannot provide a loan, right? So please visit our bank after 30 days. So now Daniel visit our bank after 30 days. Now let's check for the John. Now John needs 28,000 rupees and we have available 30,000 rupees. So yes, we can provide a loan to John. Now suppose we allocate 28,000 rupees as a loan to John. So now how much money available with us after providing a loan to John? 2,000 rupees, right? Now we are providing this money as a loan, so John will return this money after some days, right? So suppose John will return this 28,000 rupees after 30 days with some installment cost, and the installment cost is suppose 4,000 rupees. So now let's check how much money available with us after this money returned by John. So previous money available is 2,000 rupees, plus John will return this money of loan. So now we have 30,000 rupees plus the installment cost 4,000. So now we have available 34,000 rupees. Now John's request is successfully completed. Now we need to provide a loan to Daniel and Smith. Now let's check for the Smith. Now Smith needs 40,000 rupees. We have available 34,000 rupees. So we cannot provide a loan. So again telling Smith that okay Smith, we cannot provide a loan. Please visit our bank after 30 days. So now Smith will return to our bank after 30 days. Daniel again visit our bank. At this time we have available 34,000 rupees while Daniel needs 32,000 rupees. So yes, we can provide a loan to Daniel. So let's provide a 32,000 rupees. So now how much money available with us? 2,000 rupees, right? Because 32 is allocated to Daniel. Now, as this money is provided as a loan, so Daniel return this money after some days, right? So now suppose Daniel will return this 32,000 rupees after 30 days with the installment cost of 8,000 rupees. So now let's check for the available money. So now the previous available money is 2000 rupees plus after 30 days Daniel will return this 32,000 rupees. So now again we have 34,000 rupees plus the installment cost is 8,000 rupees. So 34,000 rupees plus 8,000 rupees. So now we have available 42,000 rupees. So now John's and Daniel's request is successfully completed. Now Smith again visit our bank. Now let's check for this request. Now we have available 42,000 rupees and Smith needs 40,000 rupees. So yes, this time we can provide a loan to Smith, right? So let's provide a loan. So now after providing a loan to Smith, how much money available with us? 2,000 rupees. Now as this money is provided as a loan, so after 30 days Smith will also return this loan money to bank with some installment cost, and suppose the installment cost is 8,000 rupees. So now let's calculate again the available money. So previous available money is 2,000 rupees. Then Smith will return 40,000 rupees. So 40,000 plus 2,000 which is 42,000 rupees plus the installment cost is again 8,000 rupees. So 42,000 rupees plus 8,000. So now we have available 50,000 rupees with us. So using this algorithm, we can provide a loan to our all customers. And here we must need to follow this sequence to provide a loan to our all customers. And the sequence is John, Daniel, and Smith. If we provide a loan to our customers in this sequence, then and then we can provide a loan to our all customers. So this sequence John, Daniel, and then Smith. This sequence to provide a loan is something known as safe sequence, because if we provide a loan in this sequence, then and then we can provide a loan to all customers. So this sequence is something known as safe sequence. So what basically we are doing here is we provide a loan to our all customers and we are trying to find out some sequence so that we can complete all the requests. So the same funda is used in safety algorithm. Same the steps are followed in safety algorithm. So instead of these customers we have a process, and that process is a requesting for some resources, and what our job is to complete their request in such a manner so that we can complete the request of all processes. So now let's see the algorithm, the actual step of safety algorithm. So here is the safety algorithm. Please guys, don't try to mug up this algorithm. Just remember that previous example of providing a loan to our customers. That same steps are followed here and you can easily write this safety algorithm. So in the starting of that example, we need two types of data. The first thing is how much money available with us, right? And the second thing is how many customers are looking for a loan, how many customers are requesting for a loan. So same step is followed here in safety algorithm. The first thing is we need data that how much resources are available with us. So we create one variable and initialize it with the number of available resources. So one data we have. The second data is how many customers are looking for a loan, right? So here we are following the same steps. Suppose we have n process in our system and we assume that all n processes are requesting for some resources. Now if process is requesting for some resource, it means it is not successfully completed, right? So what we are doing here is we create an array of n variable and initialized it with the false. It means all n processes are not completed. It means all are requesting for some resources. So now we have two types of data. The first is how much money available with us, and second is how many customers are requesting for a loan. So in second step, what we are doing is we try to find out such a customer so that he is requesting for something and we can provide him a loan. It means we are trying to find out such a customer so that his need is less than the available money, right? So here same step is followed in safety algorithm. We find such process I such that it is not successfully completed. It means it is requesting for something and whatever money he is requesting is less than the available money. But here instead of money we have process. So we find such process I which is not completed. It means it is requesting for some resources and we have available that number of resources. So till now what we have done is we found John. So after finding John, which step we follow? We provide him a loan. He will return all money back to the bank and we change the value of available money. So same step followed here. We change work is nothing but available. So we change the value of available by adding all the allocated money. So available plus equals to allocated. It means that the process is successfully completed and it will return all the resources back to the computer. Now the resources process is successfully completed, so we change its status to true. It means the process is successfully completed. So till now what we have done is we found John, provide him a loan, he will return all money back and we change its status to it is successfully completed. After that what we have done, we find again new customer so that provide him a loan. So same step we follow here. Again go to the step 2 and find such a customer so that we can provide him a loan. Actually I forgot one thing here is if no such I found, then what we do is we go to the step 4. Actually step 4. Okay, why we write this step? Because think in a previous example, after providing a loan to our last customer Smith, he will return all money back to the bank. So at that time available money is equals to 50,000 and we change its status to it is successfully completed. But as per the safety algorithm, we again go to the step 2 and find that any new customer is requesting for money. But no, all customers requests are successfully completed. So at that time, no such I found. So at that time, we go to the step 4 and we check that all request is successfully completed or not. If all the request is successfully completed, then system is safe, else system is unsafe. Okay, so when this unsafe situation happens, suppose in the previous example, after providing a loan to Smith or last customers, or available money is 50,000 rupees, right? Now suppose new customer is requesting for a loan and he need 60,000 rupees. So now again we go to the step 2. At this time, yes, there is a one customer whose request is still not successfully completed, but at this time his need is greater than available money because his need is 60,000 rupees and we have available 50,000 rupees. So and at that time, again no such I found. So we go to the step 4. In step 4 we check that all process is successfully completed or not. But no, the last customer's request is not successfully completed. So this situation is again, this condition is again false, and we go to the else part and it will return that the system is unsafe. So now you have a clear idea of how the safety algorithm works. And this safety algorithm is the fourth and the last step of Banker's algorithm. So now let's take a whole example of Banker's algorithm so that you have a clear idea of how Banker's algorithm will avoid our system from the deadlock. Okay, so let's take this example. So this is our system, and to avoid our system from the deadlock, we have applied deadlock avoidance technique, Banker's algorithm. Now, what is the basic funda of deadlock avoidance technique? If any process wants to access particular resource, then simply send a request. Now, whether to grant this request or not, that will be decided based on the background calculation. So, same funda is used here, and for that background calculation, we applied Banker's algorithm. So, let's see how it will avoid our system from the deadlock. Suppose P1, P2, two processes are there, and two resources R1 and R2. Now, P1, P2 both are requesting for resource R2. But the first request arrived for resource R2 is of process P2. So first priority is given to process P2, right? Now we applied Banker's algorithm to check that whether to grant this request or not. So let's apply Banker's algorithm. So in first two steps, we check that whether this request is valid or not. And we find that yes, this request is valid. So what we do? We follow third step and allocate resource R2 to process P2. Okay, so now let's apply fourth and the last step of Banker's algorithm, which is safety algorithm, right? And we find that after granting this request, whether this system will lead to the deadlock or not. So let's check. So P2 is requesting for R1 and R1 is already allocated to P1. So we cannot grant this permission because it is not available with us, right? So the value of a finished variable of P2 is false. So P2 cannot successfully completed. Let's check for P1. So P1 is requesting for R2, but R2 is allocated to P2, so we doesn't have available resource R2. So we cannot complete the permission of P1. So its finished variable value is again false. So we find after completing this safety algorithm, we find that P1, P2 both cannot complete. So safety algorithm will simply return the system is in unsafe state to Banker's algorithm. So Banker's algorithm finds that system after granting this request, system will in unsafe state. So Banker's algorithm never allocate process resource R2 to process P2. So it will never grant this request. Now let's check for P2, right? Because granting this permission will may leads to the deadlock. So now let's check for the second request. Second request is of process P2. So we apply Banker's algorithm and we check that can we grant this permission or not. So we apply first and second step of Banker's algorithm to find that this request is valid or not, and we find that this request is valid, so we allocate resource R2 to process P2. Okay, so three steps is successfully completed. Now we apply safety algorithm and finds that whether the granting this request will leads to the deadlock or not. Okay, so let's check. So P1 looking for no resources because all resources are successfully completed. It means its need is now zero resources. So it means it is successfully completed. So it will return all the resources, right? It will release R1 as well as R2. So these both variable resources R1 and R2 are now free, right? Now P2 is requesting for R1 R2 both. So this both request is successfully granted and it is allocated to process P2. And after granting this permission, its need is now zero. So this will also release R1 and R2, and hence P1 P2 both are successfully completed. So safety algorithm will simply return that system is in safe state. So banker's algorithm will find that granting this request will never leads our system to the deadlock. So what basically banker's algorithm will do? It will simply allocate resource R2 to process P1. So this is how banker's algorithm avoid our system from the deadlock. Okay, so that's it for today's lecture. In next lecture, we take an example of banker's algorithm, and I will teach you how to solve examples of banker's algorithm in your exams. Okay, so that's it. Here, if you have any queries, here is my contact detail. You can mail me, you can WhatsApp me also. Please guys, like my videos and subscribe to my channel. Okay, thank you. Bye bye.